All right, we are going to start here in chapter 13 this week with pictorial drawings. I've already started to give you a bit of an introduction to pictorials with some of the isometrics that we have been doing, but this is going to go in further and give you some other ideas of how we use pictorial drawings to achieve a look or help us to visualize what we're looking at. Now, so there are several different types of pictorials that we're going to talk about. You're going to need to get to know. We're going to kind of go over how to draw these, both isometric and what's referred to as cabinet oblique pictorials. Um, the main thing that you want to take away here, of course, is that a pictorial is basically just any type of a three-dimensional drawing. Remember, all of our drawings on paper are two-dimensional. We're drawing on 2D paper, so we have to have a way to kind of make it look 3D. And this, of course, when we are able to do that, that helps us to be able to visualize and get a better idea of what it should actually look like in real life. So, when we talk about pictorials, we really are kind of talking in some ways about art work or sketches, uh, things that are really truly conveying the ideas of what our thought processes are and what these things should look like in everyday life. Um, and again, as we take a look at them, uh, we're still drawing it in 2D, but we're trying to draw in 2D in a way to make it look like it's 3D. Now, as we get more involved into the different types of pictorials, I do want to make a comment that unlike art, um, with our pictorials, we are still following a process. We're following rules. It is not quite as free form as the artistic side, but it is still going to convey and make an object look like it's 3D. Pictorials are also very effective ways to show assemblies. Here you've got a drawing of an assembly, and it clearly kind of shows how this thing should be going together. So now let's talk about three basic types of pictorial drawings. First, you have what's referred to as an axonometric. Our most common is what you are already been familiar with and have already started to draw in terms of an isometric, where we do have the horizon line. And you've got a corner of the object sitting and resting on that horizon line, and then the other edges basically extend at 30 degrees from that intersecting point. So there's your isometric. We also have what is called an oblique. Now, there are several different types of obliques. Most common is a cabinet. Notice in the oblique, we do have a full, what we call kind of like the view normal. So we do have one side of the object that is showing us true size and true shape, and then we project back from there. And then the third basic type of pictorial is perspective. Of course, the human eye sees in 1-point perspective, but we have 2-point and 3-point perspective as well. So let's start off with some axonometric projections. Now, for the purpose of this course, this is very term heavy. You do want to kind of be aware of some of these terms for the actual quizzes and tests, but be aware, outside of draftsmen and some engineers, you may hear these terms, but on the job, um, I don't know how much these terms are really being utilized unless you're really, really into drafting as a whole. So, of course, we started with the isometric. The isometric is drawn to scale, so all of these dimensions and sizes we would make exactly the same in terms of the X, Y, and Z axis. And of course, here we have that projection. Remember, we talked about that 30-degree, and that's generally the inclined edge on both of those as we go. Your dimetric would be this, instead of having the 30-degree angle, uh, the theta angle here is equal to each other, but they could be any type of angle that is not 30 degrees. So anything between 0 and 45, but would not be 30 degrees. And then the trimetric is where you do have two completely different types of angles here, so represented by angle theta and angle phi, and they would add up to be less than 90 degrees there. So those are the three types of axonometric projections: isometric, dimetric, and trimetric. And as you can see, we're back to the projector lines, or what's referred to, or what I've referred to as construction lines, where we do have projection planes. And you can kind of see as we would rotate and spin that particular object in space, you can kind of see the relationship between the intersection points and the lines drawn to connect the dots, and how all of these are kind of related to each other. So bear that in mind. That is, of course, something that we are trying to make sure that we're aware of as we visualize these object problems. So what then types of axonometric pictorials is used here to represent the following objects? So you kind of take a look at that and see if you can guess what these are. Of course, the first one's being isometric. Second one here is trimetric. Notice these angles are not the same. So you have one that's a smaller angle and the other's a larger angle off of the horizon line. Here, as we go, the next one is the dimetric, and of course, both of these angles are the same, the angle from the horizon line up, and both of those are smaller than our traditional isometric of 30 degrees. Now we're going to get into obliques. There are three types of obliques: the cavalier oblique, the cabinet oblique, and then the general oblique. And quick way to understand and think about this is the cavalier oblique basically has the projection lines of the object. Again, we do see the full face of the object, and that is what we refer to as true size or true shape. We can then, off of that horizon, or off of that face, we can project these lines back. Notice at this point, we're still maintaining parallel lines as we go through each of these, and that angle off of this horizon line can be anywhere from 0 to 90 degrees. 45 degrees, of course, is probably the most common as we go in there. And these lines that project back on our object are drawn full scale. So if they were 1 inch line, they'd be drawn at 1 inch line. The height here would be drawn at the actual height. Here on the cabinet oblique, so this is what's half scale. So it's kind of the same thing. Your cavalier oblique and your cabinet oblique are more or less the same, except here we draw half scale instead of full scale. Then we've got a general oblique projection where that scale is neither full nor half as well. So, but again, the same thing going on here. This front view that we're looking at is what we would refer to as true size and true shape. Just another image showing you how these projectors are related to each other. And then, of course, we've got perspective. Again, I mentioned that the human eye sees in one-point perspective. You're all familiar with this as we're driving down the highway. We know that the sides of the highway are parallel with each other, but they look like they converge at some point in the horizon off in the distance. That is, of course, the way the human eye sees. So here's an example: point perspective, 2 point perspective, and 3 point perspective. Now, one of the ways that you can distinguish between a perspective drawing versus a isometric or a oblique, of course, is the idea of whether the lines are parallel or not. On a perspective drawing, none of your lines are going to be parallel with each other. They're all going to more or less try to converge somewhere out in space to a single point. So bear that in mind as you're thinking about these differences between your perspective drawings and your isometric or oblique drawings. Again, here's your vanishing point out there in space, showing the projection of all of those through that plane. Visualization here as we go, this is the ability to picture in your mind how a 3D part would look. So, and a lot of what we do is to kind of play these problems off where we've got an isometric or an axometric and we go into a orthographic projection, or we're given the orthographic projection and we practice by taking a look and trying to sketch or draw the isometric. So that is pretty common practice as we learn how to do these particular objects. And visualization is a key point here. So we have to be able to visualize what that should look like in all of these different views. So as we go through, when we're using this 3D CAD, so it's going to create a lot of this for you. If you can kind of develop this in your mind's eye, though, you're going to be a little bit ahead of the game. So it will help you be able to identify when things just aren't quite right. So you can really say, well, there's something that doesn't look right with this particular drawing. Let me try to think about what that is. So here are a couple of examples. So as you're given some of these problems, you're looking at the views and you're often going to say, okay, well, which of these isometric drawings is going to be displayed and actually shown as we're looking at this? So in this case, as you kind of take a look, we're given the orthographic here, and we're seeing, okay, is it going to look like this, or that? Well, surely by now I would think that you would recognize that that is what this would actually look like as a three-dimensional object. Let's try one more here. So again, you're given the three views to kind of say, all right, well, this is what it looks like. Now, from the top view, we can see that there's a corner taken. So we've got well, there's this one right here with the corner notched out, and this one here with the corner notched out. That one is solid 90 degrees, so we can eliminate that one. We're left with these two. So we need to go and look for more information here now. Well, right here we also see that there's a hole there. So which one of these has the hole? That one has a hole right there. So that lets us know that that is the correct, indeed the correct answer for this particular problem. So as we kind of go through there now, the rest of this PowerPoint I'm going to provide for you so that you can take a look and see it. It is going to go over what we call blocking technique. We will doing some more blocking technique in actual class, but then you'll also be able to look back onto this PowerPoint and get those concepts and ideas down as well.